Hello, I'm Thomas Beatty, an astronomy graduate student at The Ohio State University. I'm here to talk to you today about KELT 2AB, the newly discovered hot Jupiter by the KELT North Transit Survey. The exciting thing about this planetary system is the brightness of the host star, KELT 2A. KELT 2A is a slightly evolved F star with an apparent V magnitude of 8.77. That makes it the seventh brightest host for a hot Jupiter known, and the third brightest discovered by a ground-based transit survey. Bright planet-hosting stars are of prime scientific interest because they provide us with the best opportunities for space and ground-based follow-up work. In turn, this follow-up work provides us with specific information about planetary atmospheres and interiors that otherwise would be very difficult to obtain. The planet KELT 2AB is in a 4.1-day orbit and has a mass of 1.52 Jupiter masses and a radius of 1.31 Jupiter radii. This is slightly inflated as compared to the Baraf models for a similarly irradiated planet at a similar age as the KELT 2 system. This does, however, fall in the middle of the distribution of the observed hot Jupiters, particularly hot Jupiters with a similar effective temperature. I've plotted here the 4 transiting hot Jupiters around host stars with V less than 9. Most of our specific information about planetary atmospheres and interiors comes from these 4 planets and others around bright host stars. You'll notice, though, that much of the plot is blank. When I add in KELT 2AB, you can see that it occupies a unique position in parameter space in relation to the other planets. The KELT 2 stellar system itself is also interesting. Previous observations from the mid-70s identified KELT 2 as a visual binary, based on the proximity of the stars which we now refer to as KELT 2A and KELT 2B. Imaging gathered as part of our follow-up observations proved the association of KELT 2A and KELT 2B based on their common proper motion. As part of our fitting procedure, we've determined that KELT 2B is an early K-dwarf with an effective temperature of about 4,900 degrees Kelvin. Here, I've shown KELT 2A and KELT 2B in a face-on circular orbit. The projected separation of the 2 components is 295 astronomical units. That corresponds to an orbital period of approximately 3,500 years. It's tempting to speculate, based on the presence of KELT 2B, that KELT 2AB was emplaced on its current orbit via the cosine mechanism. We're hopeful that future Rossiter-McLaughlin measurements of the spin-orbit alignment of the planetary system will shed light on this hypothesis. Indeed, we're generally very enthusiastic about the future follow-up possibilities of this system. As I noted previously, the brightness of the host star makes this a prime candidate for ground and space-based observations, and hopefully will provide a bright benchmark system in years to come.